welcome to the next lecture on data analysis. I did explain in the first lecture that data analysis has a lot to do with analyzing the relationship between different quantities using graphs. And I tried to illustrate how to linearize or analyze different types of equations to be in the form of y equal to ms plus c, which is the general equation of a straight line. Okay, so based on that, I cannot just explain something to you on the table vaguely. All right, I'll try to use a question from a particular. I'll use a full question where we're going to go through the analysis. We'll do the table itself. We'll explain what you're supposed to do on the table, and then from the table we'll look at the graph, and then from the graph we'll look at how do you calculate the gradient, or how do you calculate the values of constants which have been given to you in the equation. Okay, so I would like you to subscribe. If you're watching for your first time, you can subscribe to your YouTube channel so that anytime that we release any lecture, you can be able to receive a notification for it, and then you watch the video immediately. We have videos on biology, chemistry, physics, maths, and further maths, so you just have to choose. Okay, and let's continue. So we're talking about physics / pure maths, because these two data analysis comes both in maths and maths paper 2 advanced level, and also in physics. So the same rules you follow in physics is the same rules you follow in math for you to get the equation. But the difference is that in maths, in pure maths, it is a little bit easier than it is in physics. So for pure maths, you can have maybe a data analysis question. If it's a full question, you can have a question for that kind of 10 marks. Okay, but in physics, it's actually 20 marks because of maybe the volume of work that you have to do, and some very other pertinent questions that you are being asked. So it's a full question. It's on 20 marks, and you have to answer it within 30 minutes. Now, if you open your paper and you discover that you answered data analysis for more than 30 minutes, it means that you're already running short of time. Okay, so let's continue with this. I would like to read the question to you. Okay, if you can copy, you copy. I'll read it at a very slow pace, or at the pace which you can copy. It's from Northwest Smoke 2013. It says that the experimental measurements of the rate of emission of radiant energy, E, from the surface of a body show that the rate of emission of radiant energy per unit area varies with the absolute temperature, capital T, as follows. I'll read it again. Experimental measurements of the rate of emission of radiant energy, E, from the surface of a body show that the rate of emission of radiant energy per unit area varies with the absolute temperature, capital T, as follows. So which is capital E equal to capital A T to the N. Now I want us to focus on this equation, okay? And on the table, and you have been given a table where E is a physical quantity and N is an integer. The table below gives data for the radiant energy per unit area as a function of temperature. Okay, so you have been given E and you have been given the temperature on the table. So you have been given a table that contains values of E in times 10 to the 8th watts per meter. Okay, and then you have been given the theta in degrees Celsius. For example, the first value is 0.27 and the last value is 4,456. Okay, that's the first value for the temperature in degrees Celsius. I just want you to take a look at it, okay, and then we're going to move on to the next part. Okay, so that's it. That's the equation, and this is how the table has been given. Now you don't really need the values, okay, in order for you to explain, for me to explain. But when I do it, you can be able to use. I just want to use this to teach you how to plot the graphs. Now let's look at the very first thing I said we do when you want to plot the graph is the analysis. So you do the analysis. So the analysis here, when you analyze the equation E equal to A T to the N. In the previous video, we did analyze this particular equation. And we said that when you have anything to the power n or anything raised to the power, for you to be able to bring down that stuff, you must use a logarithmic function. Either you use ln or use log. It all depends on you. But I said in physics we like using ln, but in mathematics we like to use log. Okay. Anyhow, you can use log or ln in any of the cases. So this implies that if you are using ln, you apply ln on both sides. You're going to have ln e equal to ln a t to the power n. And I did explain some laws of ln to you, and this one will imply that we are going to have ln e equal to ln a, since it's a product, will be plus ln t to the power n. And we did say that, okay, if this stuff is being expressed like this, it will imply that ln e will be equal to ln a plus n ln t. Alright, if you don't know why it is like that, I gave the laws of ln in the previous in the previous lecture on data analysis on lecture 1. So you go back to it and you get it. Alright, you get why I brought down this n behind here. If it was locked, it would be the same thing. Now this implies that ln e, since I've been given a table of E and temperature, so I have to, it means I'll be plotting something which concerns E against something which concerns the temperature. So I'm going to have ln E equal to n ln t plus ln A. Okay? So why, if I'm analyzing like this, you see that my equation is in the form y equal to mx plus c. Ln E is my y, ln t is my x, n is my m, okay, and ln A is my c. Alright, so this is the analysis of the equation. Now after analyzing the equation, the next thing I'm going to do is to give the statement of what I am going to be plotting. So this was 1 and this is 2. I give the statement of what I'm going to be plotting, which is 2 marks statement. My statement of what I'm going to be plotting is, okay, a graph of ln E against ln T is a straight line graph with gradient n and y-intercept ln A. Okay, a graph of ln E against ln T is a straight line graph with gradient n and y-intercept ln C. Ln A. Alright, our y-intercept is ln A, so it represents our C. Alright. Now that is it about the analysis and what we are going to be plotting. Alright. Now the third thing that we have to go on to is the table. The third thing we have to go on to is a table. Alright, please take a look at it and we are going to move on. Okay? Now let's move on to the table. We have seen what we are going to be plotting against what? Okay, we have arranged our equation in the form y equals mx plus c. Now one advice I'm going to give you is that when you are talking about the table, right? I didn't pay so much time on the analysis and on the statement because I did that in the previous lecture. So I did a lot of demonstrations on that, and I think it's going to be very, very clear. So on the table, we have, from the table you see you have been given the values of E and theta. But remember, you have been told about absolute temperature. What you have been told about in the equation is absolute temperature and not theta. Absolute temperature is temperature in Kelvin. So whenever you see T, know that it is temperature in Kelvin. Okay, when you see T and I talk about temperature, absolute temperature, know that it is temperature in Kelvin. But theta in degrees Celsius is different. Okay, so what happens is that when I advise you, when you are being given a horizontal table like this one, because the equation was actually a horizontal table, so the values were given to you horizontally. What you do is that you convert the table into a vertical table. I will advise you to convert the table into a vertical table. That is the first thing you do. If it was horizontal, you can make the table to become vertical. The next thing is that you should copy the table that you have been given before you start adding your own table of what you are going to be plotting. So you must copy. If you don't copy the original table, you are going to be, everything you do is going to be marked wrong. It's not going to be considered, okay, because it can be assumed that you took the answer from somewhere. Okay, so what you do is that I'm going to provide a table. All right, the original table of what was given. I'm going to draw my table, and I'm going to put originally what was given to me what was given was E. I was given a table of E times 10 to the 8, alright, watts per meter, alright, and I was also given a table of theta in degree Celsius. Okay, now having E in this and theta in degree Celsius, I'm going to copy all the values. For example, the first value was 0.27 and the first value was 4,456, okay, degree Celsius. Now in the question, they are telling me about absolute temperature, and absolute temperature is temperature in Kelvin, okay, which is T. Remember the equation is E equal to AT to the power n. The absolute temperature is temperature, so I have to convert the temperature from theta to from the temperature in degree Celsius to temperature in Kelvin. So since I know that, I have to improvise, or I have to provide a table for the temperature in Kelvin. And how do we convert from degree Celsius to Kelvin? We add 273, so T will be equal to theta plus 273, okay, for us to have it in Kelvin, 73 Kelvin, alright? And if I was to convert from theta to T, okay, or from T to theta, theta will rather be equal to T minus 273, okay, please take note. So mean that for all the values of theta which I'm going to have here, I will add 273 to them to get a value of T in Kelvin, okay? And then after I have that, the table again tells me, or the question again tells me, for my analysis, not really the question, for my analysis, I saw that I'm plotting a graph of ln E. Remember our equation is ln E equal to n ln T plus ln A. Okay, so I'm plotting a graph of ln E against ln T. So it means that I have to get a value, okay, I have to get a table for ln E, okay. Now remember, when you're writing, your ln E, okay, your ln E here has to be in 10 times 10 to the 8 watts per meter, like that, alright. Please, your ln E has to, so it means that any value of E that you take, please follow up. This arrangement here tells us that for any value of E which you take, you should multiply it by 10 to the 8 before you actually have the actual value of E. So when you take 0.25, I cannot just go ahead to take 0.25 to punch ln. I'll take 0.25 times 10 to the 8 before I take the ln. Alright? Now I am not going to punch it this way. Follow it, because with just the punching, if you make the mistake, you are going to fail everything. Because if you look at it, if you punch ln 0.27, it is going to give you a negative value. And when you multiply the negative value times 10, of course, it's going to be negative. Okay? You don't take ln, let's say 2.7 or 0.27, then times 10 to the 8. No, you don't do that. Okay, because this like that is already wrong. Alright? So what you do is that you take ln of 0.27 times 10 to the 8. Because when you take 0.27 times 10 to the 8, it gives you a value, then you take the ln of the answer. So if any value you take here, you multiply by 10 to the 8, and then you take the ln of the answer for you to have the actual value of ln E. And why I'm putting everything in the magnitude sign is because ln E does not have ln of a number or ln of any quantity does not have any units. Okay, ln of any quantity does not have any units. So no matter where you are applying ln, like June 2014, okay, June 2018, you are applying ln, it has no units. Okay, so you always make sure, please, you follow this explanation I just gave. When you have something like 10 to the 8 to that or 10 to the 4 or 10 to the negative what, it means that you should take every value that you have here times that exponent, and then you can now be able to have the real value of that quantity. So ln E is written in times 10 to the 8 watts per meter, okay, and then I'm going to have my values here. Alright, I'm going to have my values here like this. Okay. Then I now take another table, and then I provide another table for ln T. Alright, ln T in Kelvin. Ln T in Kelvin. So ln T in Kelvin is not going to have any units. Ln T is not going to have any units, okay, because ln of any quantity does not have any units. So you just now you use down the link of this, you point the link of the constant or the numbers which are here under the temperature in Kelvin to provide them here. Okay, and please, this is what you do for every case. For example, if in the last video we actually tried to analyze an equation of force of the Coulomb's law, we said F force equal to electrostatic force. We will write it as Q squared divided by 4 pi epsilon 0. Okay, all that times 1 over r squared. So on the table, if you are being given a table of F and R, and you see that you are supposed to plot a graph of F against 1 over r squared, it automatically means that you have to provide another column for r squared. Okay, and after you provide a table for r squared, you have to provide another column for 1 over r squared. Okay, for you to be able to have all your necessary information which you need to plot. That is when you are going to have all the mark. You don't just jump from F and R and then you go and put 1 over r squared. No, it's not going to go. You must put r squared, then from r squared you move to 1 over r squared. Okay, so anytime you are plotting, please make sure you look at it, especially when it concerns temperature. Make sure this, if you are given temperature in theta and what they are describing is the absolute temperature, you make sure that you convert the temperature of theta to Kelvin, okay, before using. Alright, so that is it about the table. That's all about the table. That's what you do about the table. You make sure that you copy back the table you have been given, and then you provide the table for the other ones. Now, in some tables, you don't even touch the values. For example, I think June 2017, they simply just gave you, the only thing you were supposed to do was just to rearrange the equation and copy the same table, and that was all. You did not have to do anything because I quoted the equation, so they gave you E equal to V plus IR. And I told you were simply supposed to arrange the equation to be of the form V equal to negative IR plus E, okay, which could be equal to negative R times I plus E. So a graph of V against I is going to be a straight line graph with gradient negative R and y-intercept E. That was all you were supposed to do. You were not supposed to, rearrange, because they already gave you a table of voltage and current, and that was all you were supposed to do. Okay? So from the table, we are going to move on to the graph proper. Okay, we are going to move on to the graph proper, and we're going to come back here. So please, I've told you how to point. You don't take limit of 0.25 and then after you multiply by 10 to the 8. No. Okay? You make sure that you take the value first, multiply by the exponent which is here, and then you now take the mean of the whole stuff. Alright? Please. Okay, now that is our table. Okay, we have seen all the necessary information which we need for this particular equation. Alright, which we need for this particular question in order for us to plot the graph. So when you want to plot the graph, what are you going to do? You have your x-axis and you have your y-axis. Now it is not just all about plotting the graph, but it is also about knowing what to plot. Alright, it's also about knowing what to plot and how to plot it, because you can have the right information and then you plot it in the wrong way and you end up not having any mark. So how do you do it? Okay, if this is my graph, I'm going to have a y-axis, of course, and this is my x-axis. But I am not going to label it y-axis and x-axis. Now, in math, sometimes you can write the title of the graph, but in physics, please, you don't put any title. Physics graphs don't have titles. You go ahead and plot it. Don't say a graph of lane E against that. No. Okay? You don't give any title. Now, what we are plotting here is lane E. Okay, we are plotting a graph of lane E against lane C. Okay? So on the x-axis, we are plotting where the values that are supposed to be there are going to be lane C, and the values on the y-axis are going to be the values of lane E. Okay? Now, after after you must have labeled your axis, this is called labeling of the axis. But before you label the axis, okay, I would like to explain something to you. Now, if this is your graph paper, if this is your whole graph paper like this, right, and you know the graph is, you know, this is a complete graph this way, okay, and these are the squares of the graph like that. Okay, now you don't try to make your graph to be neat. Alright, you don't try to say I want to make my graph to be neat, and then you come, since the squares of the graph, these are the squares of the begin here, you want to push one square inside to come and draw your y-axis here, and then draw your x-axis this way. Okay, you draw your y-axis here and you draw your x-axis, one square inside, one square inside, and one square inside. No, it's going to be very, you're going to have a poor graph. Okay, it is good you start at the very edge of the graph paper, or the section where you have the squares. Okay, you start at the very edge, and then you draw your y-axis, and then you go to the very edge below and you draw your x-axis. Please, you don't try to make your work by bringing inwards like that. All right, please, you abstain from that. Okay, abstain from that. Then after you have done that, you can now be able to label your axis. And please, there is no law that says that if, for example, this is your graph paper, there is no law that says that the longer part, or yes, the longer side of the paper is going to be your y-axis, and the shorter side is the shorter length is going to be your x-axis. There is no law that says that. Even if you see that your values of min t, for example, can best fit along this line, you can take your paper like this, okay, and put the y-axis this way and then the x-axis like that, and plot lin E here against lin T. Of course, remember this is an example. In any other case, if you see that your values of the other side, maybe if these your values could better fit on these squares here, you can take your paper like this and make it the y and x. There is no law that says that your graph paper must be like this, and this must be the y and this must be the x-axis. Okay, so please take note of that. And thank you very much for watching this lecture. I am going to explain how you plot the graph in the next part of the lecture. So subscribe to the channel, you share the link, you comment and like, so that if there are any adjustments, we are going to do them. Thank you very much for watching, and see you in the next video.